So today we're going to talk about arithmetic sequences. An arithmetic sequence is a pattern of numbers where you get from one term to the next by either adding or subtracting the same value each time. And because this pattern is consistent, you can predict any term in the sequence. Let's take a look at this example. I have 7, 11, then 15, 19, and 23. As you can see, the numbers are increasing and they increase by 4 each time. In other words, we are adding 4 to each term to get to the next one. So we can safely say that the sixth term in that sequence, a sub 6, is 27. Why? Because they all have what is called the common difference, which is, in this case, is 4. Because we're adding 4 to get to the next term. If we were, like for example, to have another set of numbers that were decreasing by 2 each time, the common difference then would be -2. However, in this case, we have our common difference, which is represented by D, equal to 4. Now, what if we wanted to find the 30th term, a sub 30? Adding 4 repeatedly would take some time. So instead, we can use this formula that simplifies this process. A sub n, equals a sub 1 plus n minus 1 times the common difference, which is D, where a sub n is our 30th term, our a sub 30, and a sub 1 equals the first term. N would equal 30 because, like we said, we're looking for the 30th term. And if we substitute that equation, we have a sub 1, which is 7, plus n, which is 30, minus 1 times our common difference, which is 4. Now we solve according to the correct order of operations. Then we multiply here, which is 116, which would equal 123. So our 30th term in that sequence will equal 123, or our a sub 30 would be 123. Now, in this second equation, we'll learn how to find the middle term between two numbers in a sequence. For example, if we didn't know which number was between 7 and 15, we could add them together and divide it by 2. Which, when you add 7 and 15 equals 22, you divide that by 2, it would equal 11. And the same approach for finding other middle numbers, like adding 7 and 23. 7 and 23, and then divided by 2, the first equals 30. When you divide that by 2, it will equal 15. The tricky part for me comes when we deal with word problems. In my opinion, the challenge often is deciding which steps are the most convenient. So let's take a look at this example. It says, Tony is a poodle that needs to drink liquid solution in order to improve his skin condition. On his first day, he drinks a sub 1 in milliliters of the solution. The amount of the solution Pony receives increases by the same amount S each day. On the 8th day, he receives 23 milliliters of the solution, and on the 10th day, he receives 25 milliliters. Determine the value of S and how much solution did he start with. Now let's break this down. The problem gives us a few key pieces of information. We don't know the initial amount, A sub 1, so that's our first unknown. The amount increases by the same value S each day. This is our common difference. Even though they use the letter S, it's the same concept as D as the common difference. It tells us that the solution amount increases, so we know we're adding the same value each day. We also know how much he drank on the 8th day, which is 23 milliliters. And we also know how much he drank on the 10th day, which is 27 milliliters. We need two things to solve this problem. The common difference, which is represented by S in this problem, and we also need A sub 1, which is the amount he started with. To solve for the common difference, we could do various equations and then solve through that. Now, I find it easier just to know which is the 9th term and find out by how much they are increasing by. So to do that, to find out how much he's been having the 9th day, we just add how much he drank on the 8th day and the 10th day and then divide that by 2. So 23 milliliters is this plus 27 milliliters, divide that by 2. So we have that 23 and 27 added up gives us 50 milliliters. Divide that by 2 is 25 milliliters. So since that gives us 25, we know that he drank 25 milliliters on his 9th day. Which means that on the 8th day, he receives 23 milliliters. Then on the 9th day, he gets 25. And then on the 10th day, he gets 27 milliliters. So we can see that every day, the amount increases by 2 milliliters. So our S equals positive 2 milliliters. The next step is to find A sub 1. To find the starting amount, A sub 1, we substitute what we know into the formula for an arithmetic sequence, which is A sub n equals A sub 1 plus n minus 1 times S in this case, which is our common difference. The cool thing is that now we know the common difference, also known as S in this problem, and we know what he had on the 8th day. So we can plug in the values for that day in particular. So we have that our A sub 8 is 23 milliliters, of course, equals A sub 1, which is our current unknown. Our N is our 8th, representing the 8th day. And then our common difference, which we just calculated that, is 2. And then by order of operations, we continue to solve. 7 times 2 equals 14. And then we grab this guy, take him over here. And then we have that 23 minus 14 equals 9. So he started with 9 milliliters of solution. So our A sub 1 equals 9 milliliters. And that's pretty much it.